Yes, good evening, everyone. This is Michael, here to present my marketing and communication AI. First, I had to choose a data set which put in the data that was supposed to use my AI. So I chose a customer clustering Amazon MI heritage data set. So basically, it contained numerical data that would help me cluster or group the different clients, the different customers using my algorithm. So this is the link down there below that will take you to the website that I used. So the fact is that most when I speak in the set that this is the readability. Of course, to get that data set, I have to get data or a file that can be read by the AI instead of getting something that can't be read by the AI. For example, if I get a data set of images, but my AI doesn't images, so it wouldn't be compatible with the work. So getting a file of a readable file is one of the factors I considered. Database size must be limited to small portions to big portions bit by bit. Meaning here, should be able the data set should be able to read all the information bit by bit in that it can actually predict afterwards. Data must be structured, but the data must be grouped into different portions so that in that the AI can easily group it as it's being read. AI readability. The data must be data readability. The data must be related to the AI in that you can actually use it well. Then recent database must contain that information of data that is current. Instead of, for example, instead of getting data that was got in the 1980s, you must get data like one that we got in a bit, maybe like 2020. I have different factors in my database. So I have the customer score. So this shows the score of the number of times a customer uses the online market and the amount of time they spend there. So I have the next factor is customer frequency score. This shows the score, the number of times that the customer goes online and how much they spend there. So I also have the customer product search score. This shows the score of the product that the customer searches for when they're online. And then I also have the customer product score. This shows the score of the number of items that are purchased by the customer. Then I have the customer actual segment. Now this segment is where the customers will be classified or where they'll be graded. Like they'll be like these customers here are like this, so they take this product. Meaning using the different segments, one will be able to know what they actually recommend the customer. So like people in segment A like this product, on segment B for this product. So it basically helps out the AI to group them and be able to recommend the right products for them. So here I'm going to talk about the Bayesian theorem. So this is a mathematical formula used to determine the condition probability of events, especially. The Bayesian theorem describes the possibility of an event based on the prior knowledge of the conditions that may be relevant to the event. So this is the formula. It's P over A equals to P A intersection B over P. Basically, this formula helps us get the equation very well. The probability of A is related to occurring. Have this here. Probability of B, probability of A of B. This is probability of A given B, probability of B given A, and probability of both A and B occurring. Then I have the takeaways. So Bayesian theory allows you to update the predicted probabilities of an event by incorporating new information. It's often employed in finance or calculating or updating risk evaluation. The theorem has become a useful element in the implementation of machine learning. The theorem was unuseful to surgeries because of its high volume of calculation capacity required to execute its transactions. So here we have how the Bayes theorem is used in machine learning, of which this is why we need to within AI basically. So it provides a useful method for thinking about the relationship between data sets and the possibility. In other words, the theorem says that the probability of a given hypothesis based on being true, based on specific observable data, can be stated as finding the possibility of observing data given the hypothesis manipulated by that probability. Basically, it helps us to predict an event based on the possibilities that are available to us. So we have names right here. So it's a supervised learning algorithm which is based on base theory and used in solving classification problems. So this is basically used in classified learning or supervised learning actually. It is mainly used in text classification that includes a high dimensional training set. It's divided into clusters or classifiers that are most effective in classification algorithms, which help in building the first machine learning models that can help with predictions. Also predicts, so it predicts based on the probability of the different objects that that it has access to. Why it is used, it's called naive because why is it called what it's called really? It's called naive because it assumes that the occurrence of certain features is independent of the occurrence of other features, such as if the fruit is identified on the basis of color, shape, and taste, then red, Sophia, and sweet fruit is recognized as an apple. Hence, each feature individually contributes to identity, to identify that it's an apple without depending on each other. So it's divided into types. So it has the Gaussian. It assumes the feature model of normal distribution. This means if predictors take continuous values instead of discrete, then the model assumes that these values are sampled in the Gaussian distribution. It has a multinomial. It's a classifier used when the data is multinomially distributed. It's very used for document classification problems. It means a particular document belongs to a different category. And how the polynomials classifiers similar to the classifier, but the predictor values variables are independent. So these are the advantages of using Bayesian theorem. It's one of the first. It's the first easy machine learning algorithm to predict class data sets. It's used binary as well as multiple class classifications. It performs well in multiple class predictions as compared to other algorithms. It is the most popular choice for text classification. Its applicability is used in credit scoring, it's used in medical data classification, it can be used in real-time prediction. It also means text classification. We have the Bayesian networks. It's a type of graphic model that uses possibilities to determine the occurrence of an event. It's also known as a Bayesian network. So it has types, probability of two or more events happening together. For example, if the joint probability of two events and B is the possibility of both events occurring, so it is intersection B. Conditional probability is next type is a probability that event B will occur given that event A has already occurred. So these are some of the applications of the Bayesian networks used in spam filtering. It's a program that helps detecting unauthorized and spam mail. It's used in biomonitoring. This involves the use of indicators to quantify the concentration of chemicals in the human body, like blood or urine, which is used in measure the same. Document classification, it's also used in gene networks. I mean, the algorithm can be applied to genetically engineered networks in order to make predictions about the effects of the genetic variability in the cell phenotypes. This kit can be used to indicate the interactions between different genomes, proteins, or different organs or cells in the body. The difference between Epistepium and Metapentherium. The division between the two is a delegate one. It says that Metapentherium assumes that conditional independence for real period as not. This means that the relationship between all input factors independent may be not a general assumption, but this is why the algorithm is automated. It is also one reason that the algorithm is very fast. And to the algorithm, it's a difference between where the networks and where graphic networks are a graphic method that represents a set of variables and their conditional independence as well. Network theorem is a technique to assign class levels to samples from the variable available levels. This method assumes each feature's value I has independent. And this is why I put all my